Welcome back. In this video, we might talk about a function you haven't heard the name to before, but it's a function I guarantee you that you've worked with before. So the function that we're going to talk about is power functions. And your general equation for a power function is y equals a times x to the power of b. And b is a constant. So this is the general equation, which means a and b could be anything. But what you'll notice is that the variable is right here. So a couple of examples of power functions. Y equals 2x squared. That is a power function. That's also a quadratic function. What you will notice in this general equation is that there is nothing being added or subtracted to this. So it is a monomial. It's a monomial. A power function can have a positive or a negative b. Another example of a power function is y equals x to the power of -2. That is a power function. You could also have a fraction, y equals x to the 1/2. All of those are examples of power functions. So what you need in order for something to be a power function is you need your x right here, and it needs to be raised to any power. Now you might see something like this, y equals the square root of x. And you probably would think, that's not a power function. There's no exponent there. The square root can be rewritten as 1/2. It is a power function. Y equals the cubed root of x. That can be rewritten as x to the 1/3. That is a power function. So all of these over here are examples of different power functions. All you need is an x raised to some power and only one term, only a monomial. Now, talking about the graph of this is a little bit challenging. Talking about the graph of a power function, you have to really break this up into two different things. Talk about the positive b and the negative b. In the positive b power functions, you will notice that your graph always goes through the origin. It could look like that. And if we're doing a cubic, then really it would extend this direction as well. It could look like this. That's a square root. So positive b's are going to always go through the origin. Let me type that out over here. Oh, sorry. Always goes through the origin if b is positive. There we go. Oops. Okay. The negative b is going to have an asymptote. The negative b is going to look something more like this. It is not going to go through the origin. And it is not going to touch the x-axis. So a negative b will not go through the origin and won't touch the x-axis. Now, in a later video, we're going to talk about exponentials. And it's important that we compare these power functions and exponentials together. Because if you look at that negative b graph, you might think, oh, that's exponential. It's not. An exponential equation has a y-intercept. An exponential equation has a y-intercept. The negative b does not have a y-intercept. So let's talk about some features here. Let's start with y equals ax to the power of b, and that'll be positive. And then we'll talk about features y equals ax to the negative b. So a couple of things that we already discussed. Will go through the origin. Will have a point at 0, 0. That's what that means. Generally speaking, you're going to be increasing as you read left to right if you have a positive exponent. Not necessarily true, because if a is negative, then you might be decreasing. So you really have to pay attention to that. The domain here, the domain is, it's all real numbers until you start putting real life situations on this. When you put real life situations on this, generally you're going to be looking at 0 to infinity. Generally, you're going to be looking at the positive values, because when you start talking about real life situations, the x-axis represents time, and you can't go in a negative time. So this closed brace means it includes 0, and this rounded one means it does not include, that it can't touch it. And so this would mean from 0 to infinity. So it can be 0. Now, the domain, you're going to have to analyze your graph. Sometimes your domain could be from 0 to infinity. Sometimes it might be something else. So you have to analyze your graph based off of what it looks like. Did I say domain? I meant to say range. For this one here, couple of key features. Will not go through the origin. Will not have a y-intercept. Will not have an x-intercept. So those are things that you really want to recognize. That being said, the domain is going to be from negative infinity up to 0, but it's not going to touch it. And so I'm going to put a rounded parenthesis there. It cannot touch 0. This little u means union, so it means and. It can also be I meant to say 0 to infinity. So this madness right here is saying that our domain is from negative infinity to 0, but don't touch 0, and then 0 to infinity. So really this means that x cannot be 0. X can be anything, but it can't be 0. Yeah, and then your range, if we are looking at the whole range, not just looking at the real life situation, your range would be the same thing. Negative infinity to 0, union 0 to infinity, because this is really going to look like this. It's really going to look like this, but chances are we're going to focus on this side. And if we just focus on that side, then we're going to want to restrict it dependent on real life. Okay, so power function. Power function's general equation is y equals ax to the power of b. So ax to the power of b, where b is a constant. B can be positive or it can be negative. If it's positive, then your graph will go through the origin. Your domain, just generally speaking, will be negative infinity to infinity. But if we're talking about real life, a lot of times it's going to be 0 to infinity. And then same with your domain here. Your domain, if we're talking generally speaking, is going to be negative infinity to 0 and 0 to infinity. Do not include 0. And then your range, if we're talking real life, oh, I should probably use a real pen, not a highlighter. Real life will probably be 0 to infinity. And what you'll notice is that's rounded now, because 0 does not work. If you try to plug it in, 0 doesn't work.